All right, in this video, I'm going to talk about the antiderivatives or integration for inverse trigonometric functions. Now, you'll note that there are only 3 of them here, although there are 6 different inverse trig functions that we could have. But if you recall, when we take the derivative, there was always a pair of different ones. Sine and cosine got you the same thing, only the cosine was negative, and similarly for tangent and cotangent and secant and cosecant. So we only really need one for each of those pairs. You can always just make the other one negative and it'll be fine. And you can convert it if need be. But let's take a look at this problem 397. So first of all, what happens if I want to try to have u equal to 9 minus x squared? Well, then du is going to equal negative 2x dx, but I don't have a 2x to get rid, or an x to get rid of. The 2 is not an issue, but there's no x to cancel, so I can't use this. So this is going to be no good, right? All right, so let's take this another way. This one looks like version 1. So here, well, let me redraw this. This equals integral of 1 over 3 squared minus x squared. So here a is equal to 3, and u will be equal to just simply x. So I don't even need to make a u substitution here. I'm just going to be able to use that. And so here I can let u equal x, so du equals dx, so there's no problem. So let's see, then this is going to equal, once we take the integral, it's going to be equal to just the inverse sine of u over a. So here u is just x and a is 3, and then plus that c. Now say that instead of an x squared it was like 4x squared, something like that. Then our u would be 2x, and we would have a 2 to deal with because du would be 2 dx. In number 400 here, we'll show how that works. So we're going to let u equal, what do we have, 4x. So then this really equals integral of 1 over 5 squared plus 4x quantity squared. And that should be dx, not du. Well, this means that du is equal to 4 dx. So I'm looking here at 1/4 of this 1 over 5 squared plus u squared du. So I'm going to be able to use that number 2, but I have a 1/4 to deal with, so it'll be very close. So that'll be 1/4, and what I'm left with here is this 1 over a, so 1 over 5, here a is 5, inverse tangent of u over a, so that's u is 4x, and then plus c, which means I have 1 over 20 inverse tangent, 4x over 5, and then plus 120 times c. 1 over 20 times c is still just some c, so it's still a constant. So that's how we deal with these, whether we have a u substitution necessary or not.